Ladies and gentlemen, welcome back to the shop. Today we're going to continue the inspection of the Shars 3-jaw chuck, and what we're going to do is throw an indicator on it and check the run out as it is out of the box. Now, in order to do that, it needs to be on a standard backing plate, and if you've seen my backing plate series, you know that this is not a standard backing plate. It is adjustable. However, when I recorded this segment, I had not yet finished the backing plate. I did not drill these adjustment screw holes in the outer perimeter, and I had not turned down the diameter of this inner adapter. Therefore, it was basically a standard backing plate. Yes, it was in two pieces held together by screws, but there was no adjustment to it whatsoever. After we do that, I'm going to talk a little bit about what I forgot to mention to you guys during the backing plate series. So let's get right to it. All right, I have an indicator on the outer edge of the chuck, and we're going to test the run out. I couldn't find my test certificate. I think I might have thrown it away. But we got the dial set to 0. We're going to do a turn on the chuck and see how much the run out is on the outer edge. I believe on the test certificate, I believe it was within a couple thousandths. I'm not entirely sure, but we'll give this a little spin. And I'm going to use the counter shaft on the Alright, so we're still at 0. Now we'll give it a little spin. Still at 0. Now we're coming across one of the jaws. Still at 0. It's fluctuating a couple tenths. That might just be me, shaking the lathe, trying to turn the spindle. Now we're jumping over a jaw again. Now we're sitting at about 1/1000th of an inch. Hit another jaw. Now we're coming back down to 0. And we're back at our starting point. So the run out of this chuck on the outer edge looks to me about 1/1000th of an inch. And that's right in line from what I remember of the test certificate. All right, we got the dial set to 0 on the face of the chuck. And I took the jaws out. And I have the dial set in such a way that it'll jump the gaps where the jaws go. So we'll give this a little spin. We're currently at 0. Now we crept down to -2. We hit the gap. Came back up to -2. Sorry, I bumped the camera with my head. Now we're creeping back to 0. Another gap. Now we're back at the start, which is 0. So the face run out is about 2/1000ths of an inch. Again, according to what I remember of the test certificate, that's right in line with it. All right, we're set up. I got a piece of 3/8 drill rod in the chuck and my dial. We're going to test to see if there's any run out of the clamping surfaces of the chuck. So we'll run this in. Let's see, I want to move 0 over there so you can see it. There's no glare on that particular part. So we'll get this to 0. And then we'll test this run out. So again, we're at 0. And we're at the first jaw. Still at 0. At the second jaw, we're -1.5. At the third jaw, We are -2. And we're back to 0 at the first jaw. So we got about 2 thousandths of run out. And for a cheap 3-jaw chuck, that is pretty acceptable. Yep, now we're at 2.5. It must have been a fluke. All right, so 2.5 thousandths run out. Again, even with that, with these cheap chucks, that is, I was expecting much worse. All right, as you saw, this little chuck performed very well. For as cheap as it is, to only have a few thousandths run out of the box on a standard backing plate is just phenomenal, in my opinion. And I would say that I would recommend this chuck to any home or hobby machinist out there who needs to get a new chuck. It is a very good one for as cheap as it is. Now, what I failed to mention to you guys during the backing plate series is that when you're using an adjustable chuck, make sure that you use the same pinion to tighten the jaws every single time. That is, you pick a pinion to tighten the jaws, make your adjustments to set it to 0, and anytime you use the chuck, use that same pinion every time. Now with this particular chuck, it's been made easy because right here there's a recess with the Shars logo, and it's directly in line with this pinion. So I know every time I use this chuck, I will use this pinion in line with the logo. Now you want to use the same pinion every time, because if you use a different one, that's going to throw the run out off. And the reason for that is the scroll inside the body has a little bit of slop to it, and it needs that little bit of slop so that it can move freely. Now when you use the same pinion every time, the pinion is taking up that slop in the same position every single time. If you use a different one, of course it's going to take up the slop in a different position, and that's what's going to change your run out. Now the chuck the way it is now, since the backing plate series, I have been playing with the adjustments, so it is a little bit off right now. I believe it's about 1/1000th of an inch off, but I have the same piece, or the same reamer that I used in the backing plate series. I have it tightened with the pinion that I used for the adjustment, which is the one next to the Shars logo. We'll bring in our indicator to 0. We'll give it a little spin. As you can see, the chuck has about 1/1000th of an inch run out as of right now. Now, to illustrate how it changes with different pinions, here's the logo. I'm going to go to the pinion to the right of it. We'll loosen it, and then I'll tighten it back down. Bring in our indicator. Here we're at -3. And then we go back to 0. So this pinion that's to the right of the Shars logo has 0.03 of an inch run out. Now we'll go to the other pinion. The Shars logo is here. We'll go to this one, which is to the left of the logo. There we're at -2. And then we go to +0.5. So that pinion has 2.5 thousandths run out. And now we'll go back to the pinion that's in line with the Shars logo here. As you can see, we're now back to our original 1/1000th of an inch run out. Now, it's not just this chuck that has that problem. All adjustable chucks have this problem. Even the more expensive ones, your bucks, your bisons, your gators, they have the same issue. Now, granted, the tolerances of those chucks are a heck of a lot tighter, and you more than likely will not be able to measure the run out of each pinion with this type of indicator. You'll more than likely need a 1/10 indicator. But the issue is still there. And if you're doing real precision work, which you really shouldn't be doing with a scroll chuck anyway, but if it's all you have, it is something you need to keep in the back of your mind and be mindful of. That'll do it for this video. Thank you for watching. I'll see you next time.